In the previous video, we were talking about the example in which we create a one-way pipe from a parent to a child. That video ended abruptly, so I'm going to continue in this one. So a quick recap, we were going over this example and we already talked about part 1 where we called the pipe system call. We passed the pipe file descriptor argument, which had two indices in that. File descriptor 0 was used to read from the pipe buffer, and file descriptor 1 was used to write to the pipe buffer. And this is where the pipe buffer is, and this is used for reading from it, and this is used for writing to it. And the first thing that we did was to check whether that it returns a value less than 0. If it does, that indicates that it couldn't open the pipe, because it is expected to return two file descriptors, pipe fd0 and pipe fd1, which are used for open for reading and writing to the same pipe buffer using a first in first out basis. So we talked about this in the previous one. Then we also started talking about how after we use this pipe, we can use a fork system call to make two copies of the parent. So now we have the parent process over here and we have the child process as well. And the fork system call is returning a value, fork value. Fork value is going to be 0 in the child process. Fork value is going to be the process ID of the child process for the parent process. But first we check whether the fork value is going to be equal to -1 or not. If it is -1, that means that we couldn't execute fork and we are going to exit out unsuccessfully out of this. Otherwise, we then check for whether the process is a child process or a parent process. So we check fork value equals 0. If it is fork 0, that indicates that it is a child process. So we are going to do a printf to the standard output saying child, my process ID is. After that, we are going to get the process ID using this system call, and in this case, because we are in the child process, it is going to retrieve the process ID of the child and print it along with this printf command. And as you can see, we have the two processes, and because they are both executing the same, they are clones of each other right now. The child has a way to communicate with the pipe, as well as the parent has the way to communicate with the pipe. And as you can see, 0 is used to read from the pipe, 1 is used to write to the pipe for both parent and the child process. Now we can close out a few file descriptors here because they are not going to be part of this example. So for example, the first thing that we do is we are going to close the right end of the pipe for the child. So as you can see, child process is over here. We are going to close the right end. So we are going to close out that particular end, so that now we are only able to read from the pipe buffer. So pipe buffer reading is okay. Next, we are going to now from now on, we are going to read from the pipe as far as the child process is concerned. And the way we are reading it is by using the read command. In this, the first argument is the file descriptor from which we are reading. So in this case, because we are reading from the pipe buffer, the file descriptor is appropriately written as pipe fd index is 0. And followed by where are you reading it in the buffer, which has been initialized to 100 size character type, followed by the size of the buffer. This is going to give you a 100. So we are going to be reading to that buffer from the pipe buffer in this case. And if that read command results in n bytes to be less than or equal to 0, that indicates that we couldn't read from the pipe, and that's what we are going to throw as an error. Next, we are going to write out the data through standard output. So for example, on the screen, using the standard output file descriptor of 1, we are going to write a few statements. So for example, we can say write 1, which is the file descriptor of the screen output monitor. We are going to write child says this is what I read from the pipe, followed by 41 bytes or 41 characters. That is the total length of that 41 characters for the message. And followed by what we can write is write again to the standard output the value of the buffer and the size of that buffer. And over here, as you can see, buffer is getting the information from the read end of the pipe here. And after that, we are going to successfully exit out of this process to do other things. Now, before we did this, we were doing all of this inside the child. And if our fork value is not equal to 0, which we will be starting to look at this else statements. So in the else, which means fork value is not equal to 0, the printf is going to say parent. So we are now going to be clearly in the parent process. So the first thing that we are going to say is parent says my process ID is, again we are going to use the get PID system call, and because we are in the parent process, we are going to get the parent process ID, and we are going to print it over there on as a printf. Then we are going to retrieve the child process ID, which is going to be the fork value. As we said earlier, the return value in the parent is going to be the child process ID. So fork value, child PID is set to fork value in this case. And then we do another printf where we write parent says my child's PID is child PID here. So by using that return value of the fork system call in the parent, we are able to show the child process ID. Next, we are, this is already closed. We were not able to write to the pipe buffer from the child, so let me do that. We are also closing the read end of the pipe as far as the parent is concerned. So we are terminating this read end for the parent process from the pipe buffer. So now the way it is set up, the parent can write to the pipe buffer and the child can read from the pipe buffer using those two file descriptors 0 and 1 respectively. So we are going to close that read end by using close command followed by the file descriptor 0 here as far as the parent process is concerned. Then we are going to write, the parent can write to the pipe as follows. What are we writing to the pipe? Right now we are not writing to the pipe, we are writing to the file descriptor 1. So that's on the standard output screen. On the standard output screen, we are saying parent says this is what I wrote to the pipe, colon. So that is total of 41 bytes. Notice these are ASCII characters, and an ASCII character is 8-bit. ASCII character is 8-bit or 1 byte. So the number of characters should be the same as number of bytes here, and if you count, there will be a 41 characters over there. So on the screen, file descriptor 1, the parent is going to write this is what I wrote to the pipe, the 41 characters or 41 bytes, followed by another statement which is write to the same screen hello baby exclamation point new line character, which is a total of 12 bytes. Notice the new line character also counts as a character, and the space also counts as a character. So we are going to simply write those two to the screen. Notice this is not to the child, this is just on the screen. Then we write to the right end of the pipe provided by the file descriptor 1 hello baby exclamation point a new line character. Those are 12 characters, and if you are able to write this and if that does not equal to 12 characters, then the parent says could not write to the pipe. Otherwise, that will be a successful write to the pipe buffer using the file descriptor 1. And inside the child, we are of course reading the read end using the file descriptor 0 and putting that value in the buffer, which will eventually write onto the screen. So there's one example where we see how a parent process could write to a pipe buffer and the child process could read from the read end of the pipe. Alright, so I hope this was helpful, and now I believe you are ready for the activity.